Hi, and welcome to this introduction to deep compositing in Nuke 11.2. My name is Chris Wetherly, and I'm a product specialist at Foundry. The reason that I wanted to give this talk is to provide a jumping-on point for people interested in working with deep who's never had a chance to look into it before or understand it. And I also wanted to tackle the assumption that you needed to be working in a large, complex visual effects house or studio to use deep data. Deep has progressed quite a lot in terms of the workflows and how artists are using it. So I wanted to highlight how individual artists can start using deep to enhance their workflows as well. So with that said, what is deep compositing? Well, the easiest way I like to think of it is comparing it to a 2D image. So we know a 2D image is a representation of color pixels. Each pixel has one sample, and that sample contains all your channel data. So your red, green, blue, alpha, diffuse, all that good stuff. With a deep image, each pixel is made up of a range of samples going back in space to represent depth. So every sample will have its own channel data, so its own RGBA, and therefore each pixel in depth will let you know, it will have its own color values and alpha values, which allows you to understand what an object looks like in that depth space and allow you to do really cool things with it. So rather than describe it here, I think the best way is to just jump into Nuke and have a look at it. So I'm just going to jump away from here onto my node graph. So here we have a deep image that I'm reading in. And at the moment, it's just displaying in a traditional 2D image. But what we can do is use our deep to points node and connect our deep image with our camera. And then when I shift into my 3D viewer, we can actually see and visualize that deep data. And here we can see how in depth, it's really telling us the distance between those pixels and the camera itself. Now, a lot of people look at this and think it seems very similar to a point cloud, and it is in some ways, but what's really important about it is when I zoom in and actually look at those individual samples to describe the pixels back in depth, you get a lot of information on these edges and almost have like a smearing look to it. And this is really integral to deep because those samples on the edges are informing you what that pixel looks like at different stages in depth, and also what the transparencies look like at different stages of depth. So we can use all those samples to calculate really nice edges and really nice holdouts. And this is a big difference to deep to other workflows. And I'll touch on that a little bit more in a second. So what are some other ways to visualize deep data? Well, if we jump back to our deep image in the viewer, we also have a node called the deep samples node. And this is another really useful way you can visualize the deep data, but in its raw data format. I can just move this position icon around, and I can start seeing the actual sample value, so the distance this pixel is away from the camera. And when we get to edges where there's lots of overlap and there's lots of extra data going on, so here we're looking at a pixel which has loads of elements showcasing in depth, then we get a range of samples and more information to work with. So I'm going to just quickly enable a volumetric element as well that I'm working with, and we'll have a look at this. So with our robot, when we looked at it in the deep to points node, we were looking at a very optimized robot. So the samples were pretty much just working for the front-facing version of it, but we can actually generate more samples that will inform a complete shape of an object, so we can tell what the samples look like throughout the image. So as you can tell, this volumetric is a lot heavier. We have a lot more samples involved. But in doing so, we can start to see how that sample data can be visualized and how we're getting more information through the samples in the back. So using volumetrics is a great way to showcase how you can get really good holdouts in deep data because it's just placed in the right point in space. So when we view that, we can have these nice little holdouts and it going into the nice edges. So another thing that you'll typically see when working with deep data is you might just be given a deep pass by itself. If that's the case, there's not going to be any RGBA data. There's only going to be a deep data. And it will look yellow when you first look at it, typically. So all you want to do is just f-stop this down. Actually, I'm going to switch to a different frame so I can see it better. And now we can see all of that deep data and what's being shown. So this is a quick way to check whether you have deep data in your shot and what it looks like. Now, if you have deep data by itself, you're going to want to combine it with your RGB information. So we can take our RGB pass, and frame hold it there, combine it with our deep data using the deep recolor node. This simply takes the deep input and the color input and combines them together so that we can get both the RGBA data and the deep data in one place. So I'm just going to jump back into my slides And we've just looked at how you can visualize deep data, and that's a quick way to get up and running with how you start working with it. So the next thing I want to touch on is the differences between deep and Z-depth, because I think a lot of artists either know about depth data or confuse it with deep data, because there are similarities, but a lot of differences to take into account. So Z-depth is essentially a pass that gives you the distance of a pixel from the camera. So we're going from the camera, and this is a side view of a sphere, and we're just hitting that front pixel, and that's the information we're getting, and we're getting that for all around the sphere. Deep data does the same. It gives us the distance of a pixel from the camera, so we get all those pixels around the edges, but also all those distances in the multiple samples contained within the pixels. So like when we were looking at the volumetric, all that extra data. So Z-depth was first implemented as a way to avoid having to create holdout maps for every layer. It would use its depth pass to determine each object's distance from the camera and just order them correctly, so you could just combine them together and they would hold out appropriately. And both Z-depth and deep have this in common. However, why would you use deep instead of Z-depth? Well, Z-depth, it gives the depth of a pixel by being determined at a single sample point. And this can result in artifacts where you have edge overlaps and transparencies. And it's typically Z-depth not knowing how to handle that. So for instance, if a Z-path is anti-alias, so your edges are getting a bit of transparency, then the edges could be considering that they're shifting in depth to nothing, instead of staying in an accurate distance like you'd get with the deep samples. So with depth of field effects, you're likely going to need to render with anti-aliasing, and this can lead to artifacts and something we want to avoid. And these are the most common problems when working with Z-depth, getting artifacts when working with semi-transparent objects, motion blurred objects, or depth of field objects. So I actually just want to showcase slight differences between using deep and using Z-depth. So here we have a deep example, and pretty much the same, but with Z-depth. And when we zoom in, actually, we can show the difference. We're using the depth pass to show the depth data. And when we sort of stop down a little bit, you can see that difference in the colors representing the distance away from the camera. And if we look at the red channel down in our viewer, you can see how the number changes depending on how far away I am. And what we can see is that the edges are quite harsh. They're quite alias. They're not really the nicest looking edges. Whereas if we compare that to our deep data, we get really nice edges. And this is because of that sample data we talked and looked at earlier. Having all that extra information allows us to really understand what the pixels should look like and be calculated in depth and allow for really fantastic holdouts. So jumping back in, using deep data, you don't have to worry about these potential artifacts and this loss of quality in edges. So really knowing when to use deep or Z-depth becomes a question of, does the shot have semi-transparent objects? Do you need accurate motion blur or depth of field, which are going to introduce transparent pixels? Or do you even need to place an element inside another object or volumetric? Because again, this is where deep is able to do things that other systems can't. Using that samples, it allows you to know where pixels should blend and merge between each other and really integrate nicely. If it's no to these, feel free to use Z-depth. It might give you the results you want really quickly. So let's actually touch on the advantages to deep compositing and some of the things to be aware of. When you're working in deep, holdouts for the deep objects you create are free. This means that if there's any animation changes or environment changes, it will automatically update because we know where all the samples exist, and then when the changes are loaded in, Nuke can use the deep data to work out where each element belongs and how it should be held out between each other. This also, again, means better edge quality. So, we're really focusing on introducing a higher end output for our image. Element order also doesn't matter in deep. You no longer have to do your merge overs and unders. You can simply use the deep data, and Nuke knows whether they go in front or behind of each other. Really makes life a lot simpler. You also have the ability to simply move deep elements in a scene. So obviously, we can translate pixels in X and Y in traditional 2D comping. But with deep data, we can move it in Z-depth as well. And again, have it all still persist with the correct holdouts. I'll show a little bit of that later. You're also going to accurately place objects in volumes, as we've kind of touched on. But that also means it's easier to build an element library if you render the elements and the volumetrics with deep data. In doing so, because you can automatically generate the holdouts inside of Nuke, you don't have to go back and re-render. And this is a big part of deep, because as we'll see in a sec, deep data does require more of a storage hit, which takes longer to render. But if you're getting that back because you're not having to re-render, because you're gaining so much more flexibility with the ability to move elements with deep and have holdouts be given to you and update inside of Nuke, then actually you get a more powerful and quicker workflow. Another thing to note is that you can get high-quality convolution operations in post. So, well, what's a convolution operation? It's essentially an operation on two functions to produce a third function, and that third function expresses how a shape is modified by another. It's a horrible description, so just know that in compositing, it's typically your motion blurs, your defocuses, or any techniques like that. And the important part of this is, again, the edge treatment, and how using deep you can avoid those artifacts. Now, a lot of people sort of think about deep compositing and they assume it's more focused on volumetrics, but what a lot of the large studios use it for is really the edge quality. And this is especially true when working with complex edges like fur or hair, or with effects like blurring techniques. So really having both of best of both worlds of getting that high quality edges and those high quality volumetrics is really two cornerstones to using deep data. So some of the things to be aware of, always less fun part, but deep data requires extra memory to store. All that sample data needs to be put somewhere, and on average, files can be 10 times larger. This is really dependent on the shot or the scene. This is just a rough starting point. It'll be dependent on how you're working with deep. It can also be slower to process because of all that sample data, but we're finding with technology improvements, as everything gets faster, we're going to see that impact us less and less, and it's going to mean deep data is just going to be an instantaneous thing that you can start working with. And we're not resting on waiting for the technology to do this for us. We're improving Nuke all the time, and in the 11.2 release, we've got better memory handling to make working with deep much faster. You also have a smaller sample of deep-specific tools to work with, so this means that you don't have access to all the nodes you would in 2D. But with deep, you can actually switch back and forth into your 2D compositing space, so you can take all the benefits of deep, that edge quality, those updating holdouts, and then go back into 2D comp to access all the other nodes you need to work with. So let's actually jump into some deep workflows and how you can start using deep to improve your work. And again, I'd like to reiterate, some of the stuff I'm going to show you is just me as an individual artist. I'm not working with a large team here. I'm generating my own deep data at times and working with a single deep element. So I'm just going to jump across into my node graph. And this is a really cool project provided to us by Aaron Sims Creative. So they were kind enough to let me butcher it for this demo a bit. So the first thing that I want to showcase is we mentioned earlier about the ability to have deep transforms and deep merges. So here I have my deep merge node. And you can see I'm just chucking in a bunch of deep elements all together. It doesn't matter about the order. I've just plugged them in anyway. And they're all holding out in place exactly where I need them to be. And this is a really nice way to work. And if I jump down here and actually look at our final output over the back of the image, you can see that we've got all these different robots. And I want to focus on this little guy in the front. What I can do with deep data is use my deep transform node, and I can move him about the shot. And as I move him, he's just being held out exactly how I need to. And if you've got animation changes and you previously had to create a bunch of rotos for this, we don't need to do that anymore. It will just hold out exactly where we need to. We can also do this in depth as well. So in this transform, I'm changing my Z value. So if I just disable that, then we can see he jumps forward in space, and we can actually hold out against this roto shape that I've also converted to depth. And Nuke just automatically knows where to position everything. So it's really intuitive and simple to work with, which is a really good aspect to working with deep compositing. So the next thing that I kind of want to show you is we have this shot, and it's primarily based around this big robot. And what you would traditionally do in a comp where you need to create roto holdouts is I'm just going to come down here, look at this output. I've added an element here, just this 2D pipe. It's not amazing. Think of it more of a slap comp. So this is where I butchered the great work of the Aaron Sims guys. But you can notice that there's a certain point where his gun needs to be placed over the top of the element. And with traditional 2D comping, I'm going to actually have to come in and create a separate roto area for that and just merge that over the top to achieve that effect, because otherwise it will appear behind. It's a very simple, very quick technique. But the trouble is, if there's any animation changes, if there's any changes to anything, I've got to come in and I've got to change my roto shape. I've got to adjust the animation of the merge over and things like that. And this is a simple example. Imagine you've got a load of a crowd that you need to create complex rotos for in moving in and out of cars or something like that. You're going to have to update a hell of a lot of stuff. So instead of doing that, I can do the same thing but working in deep. And I can actually generate my own deep data to make things easier. So here, I've already rendered out that tank into deep. And I'm just combining that with my robot elements. So here, I'm just going to view all of that data inside of my 3D viewport. So you can see all I'm doing is creating a simple one sample card. I'm not needing any more deep data for that. But I'm able to see where it exists in space in relation to the robot. And when the robot reaches over, it will automatically hold out that for me. So I don't have to do this work. And if there's any other updates to the robot's animation, again, it will continue to hold out as I need it to. Now, another thing you might notice is this weird white cube here. And I'll actually get into that in a second, because this is deep data that I've generated. So part of the shot and the work we need to do for it is holding out the robot against these cubes in front of it. Now, traditionally, you would just roto these out, just create roto shapes for it and work with it. And it's still a really viable way to work. But another nice way that I like to work is take that 2D knowledge you have and start using it to create deep data. So here I have quite a traditional 2D workflow where I'm taking my camera, I'm holding a specific frame on it, and I'm creating a roto shape around these box objects, and then projecting it onto a card. So they end up with a scene which kind of looks like this. And I'm creating a point cloud earlier in my shot just so that I know where I can place my cards to accurately reflect where those boxes are in the scene itself. Now, I've got two different methods that I'm using here. One is with a card, but another method that I'm using is actually creating a box. And the reason that I want to create a box is I can use the volume of the box to generate more sample data. As we looked at earlier with that tank I generated, it only had one sample, so it showed as a flat card. If I put my roto shapes and project them onto a box, I can actually use that to generate further deep data, which will really help with holdouts with volumetrics. So where do I get this deep data from? Well, it's very simple. It's from the scanline render. If I go to my scanline render, I get deep data for free out of it. And you can test this by simply creating a deep node and plugging it in. Deep nodes will only connect to anything which shares deep data. The other nice thing about this workflow is because I'm doing a frame hold, I only have to do my roto shape once. And then because of how the camera moves in the scene, so I'm just going to disable these frame holds so we can visualize that. So because of how the camera moves in the scene, it knows exactly where these cards exist and these cubes exist in space. So that roto holdout stays in one place, and it will move with the shot. Now, it doesn't mean you're going to get a perfect roto straight away. That would be the dream. We do have to come in and modify the roto shape for changes in perspective in the shot. But it's a lot simpler because I only have to just make smaller adjustments rather than animating across the entire shot. So now I'm taking the output of that deep data of the scanline render, and I actually don't need this. I'm first using the output to act as a stencil for my tank shadows, and that's getting merged over the top. So unfortunately, that doesn't seem to have held because I made changes to my group shadows earlier. But imagine the holdout actually happening there. We'll just check if it's working over here, because if it is, I can bring that across. No worries. So with those shadows then, with that data that we're pumping out of the scanline render, we can actually use that to, like I said, hold out against the deep robot. And that's what we showed earlier when looking at the deep to points down here. That white box that we were looking at was the deep data I generated based on the sample output. So we'll just let it load up for a second. As much as there are improvements with deep, whenever you start working with deep to points, as it's trying to visualize the sample data, you do tend to get a smaller hit with it. But this is something we'll touch on later in terms of how you should be optimizing your deep workflows as well, because it shouldn't just be about how you work with deep, but how everything else goes. Well, there you have it, guys. Whenever you do a demo, of course, you're going to get these instances happen. But one thing that I do like to point out whenever we have things like this is if you do experience common issues that you see inside of Nuke, you do need to tell us about it and report it to our support team, because without us knowing what things you're experiencing day to day, it's very hard for us then to go in and fix it. So forgive me while I pad a little to make sure that Studio loads up and I get into my projects correctly. So one of the important things there, I guess I'll start touching on based on the fact that, the reason that managing your samples is so important is for things like that, to prevent yourself from having instances where the tool gets in the way of you allowing you to work. So sample management, typically you're going to generate your samples by rendering them from whatever render you're using. And it becomes about knowing when to use the right amount of samples for a certain shot. So like, I find a good starting point is to generate 10 samples per object, but then with volumetrics, it's going to be really more dependent on what's going to interact with that volumetric. You also have the ability to manage your sample data inside of Nuke. So there's actually, on the deep merge node, an ability to hold out samples. So if we look at that just quickly, we can drop hidden samples. So whenever a deep element is behind another deep element, obviously we're not seeing that sample data, we could just remove it, and that'll help optimize things. So rather than risk another lockup like that, let's jump ahead into what we've been doing for the deep data. So as I was saying, I was generating the deep data from this shot here. And if we look at a deep node very quickly and plug that in, we can actually see the deep data that's being generated again. So here you can see how I'm generating deep data for these 3 elements. Now I can use that to hold out against my robot. So I'll just do that here. And you can see it's cutting into it. And I can put that right over my shot. And again, by using deep data, I'm building flexibility into the workflow. If any of those animation changes or things like that, it allows for me to adapt. And similarly, if I want to start using volumetrics, I'm just going to jump over here to this frame hold. You can already see inside the edges of the robot, we're getting really nice holdouts just without having to do anything complex or any work going too heavy. But also on this box that we've generated deep data for, I mean, it's a bit rough because it's really dependent on, the box I created was a very basic cube. If you match it much more closely to the element in the scene, or actually have the geo, you're going to get a really nice holdout. But here you can see how the volumetric just moves, like shapes around it. And we can only achieve that because I've generated the deep data ahead of time. So those are 2 really nice ways that you can start using deep to actually, integrate it into your workflows. Another thing that's really nice with deep is the ability to use your deep crop to access elements that you wouldn't otherwise. So here I'm just going to view this shot, and I'm going to use this deep crop node. And here we're specifying that I only want to see things that are contained in between the Z space 17 and 21, which is actually just this singular robot here. So that's a really nice way to just highlight it, to access the elements that I want. Now, I'm actually going to create a new deep crop node so that we can look at that a little better. Now, when it starts out, it's actually quite annoying because you only get this bounding box because it's setting the bounding box to use, so we want to uncheck that. And you'll notice our Z far is too small. It's actually cutting off everything in front of the point of 2. So I'm going to bump that up to 20, and now we have everything in our seat. And what I can do is I can come through and start slicing through all of the different deep elements within my shot. And this allows me to use that sample data to really, and actually quite finitely, cut the elements where I need them to. And similarly, I can do this for the near as well. I don't have to limit myself to going back in space. I can come forward. So it's a really nice way to isolate the elements that you need and doing it in depth. I would advocate here, again, using the deep samples so you can get the accurate value that you want to find and crop by. Another really nice thing that you can do with deep data is the ability to do garbage mats. So here I have my roto shape that's just looking at this area, and I'm just plugging that into a deep from image node, where I'm specifying the Z space I want it to to garbage map, and that's anything beyond a Z space of 17. If I look at that, and then I actually reduce this down, so let's just look at 1, you can see it cuts everything out. And as I increase it, I can start revealing in that specific area. So between the deep crop and this garbage map workflow, you can really isolate elements to a really finite detail. So it's a nice way to work. I also wanted to touch on how artists are using deep in ways that you wouldn't traditionally expect. So this is an example from Victor Perez, who was really kind enough to share this with me. And essentially, he's doing a whole cleanup workflow. So I'm just going to plug it into the input and go to the first frame so we can have a look at this. He's essentially coming in, and he has to do a job where he's got to remove this letterbox. And in doing so, he needs to not only remove it from the scene, but also any reflections of it. So that's what we're going to focus on, primarily the reflections. But he's using the same workflow we outlined earlier, using a roto shape and a frame hold from the camera to project it onto a card. And he's creating his nice card setup. So we can come in and see all of that projected. And we're going to be focusing again on this window and also this guardrail that appears in front of it. So the traditional way you'd hold it out is you'd go to that fence, you'd output that card to its own scanline render, so we can see that in its individual element. We'd also have our card generated for our window that we're going to use on top, and you just put that from the scanline render and just merge stencil over the top to get that little bit of that holdout. So this is, again, like how we can use the workflows. But rather than doing all of this, because you're getting deep data out of the scanline render for free, so we can see that with this card element we're adding in, because we're getting that for free, we don't actually have to go to all the effort of using another scanline render, making our script a little bit less efficient. Instead, we can plug in directly from the scene scanline render, from our cards one, and use a deep holdout. And we'll get the same result of holding out the card using the fence. So we can start using deep data to really shape how we're working with deep. So apologies, the frame range has shifted, so I'm not going to be able to show the holdout completely. But it's a great way so that you can start using deep data instead of your traditional workflows, or mixing it in with your traditional workflows to make sure that you get access to all the benefits and flexibilities. You might be asking yourself, well, why make this change? Well, again, because we have deep data describing this entire scene, describing this entire scene here, it means that if we make any changes, we don't have to go in and redo that roto work again. It's right there for us. So I'm just going to jump back into my slides, jump forward to where we left off. So those are a few deep workflows that you can use to start integrating deep. I also wanted to touch on the improvements we've made in 11.2 to help foster people joining in. So what's new? Well, scripts are tending to be about 1.5 times faster on processing because of the updates we've made. We've modified the API to improve memory handling with complex deep comps. And this means that working deep is just a lot smoother and nicer. If you work with any custom deep nodes or join a facility that does create custom deep nodes, then if they update it to the API, they'll also see this performance increase. Metadata is always really important for compositors. We need to maintain it throughout all of our work. So we've made it so that metadata also works within the deep workspace so that you can jump in and out of deep and not have to micromanage that. Similarly, we've updated the deep expression node, so it's practically on parity with Nuke's normal expression node. There are a few slight things that we still need to add in, but having the deep expression node allows for a lot of flexibility. If you've ever gone in and tinkered with Nuke's expression node, you know how using random function, or how using programming functions to manipulate the image can really extend your use case. So having that in deep is a massive boon. So now I want to touch on optimizing deep workflows so you don't have what happened to me just then where Nuke doesn't like it. So knowing to be efficient with deep data is really important. The first thing I'd say, though, is because at this moment in time, the technology isn't quite there where it's just so easy to plug in and play, you do have to think about the resources. So I always start by asking if the benefits of working in deep are right for the resources required that I have to put into it. Because as an artist, it's my responsibility to understand all the options and workflows available to me to get the shot done on time and to the quality I need it to. So with deep data, again, I'm looking for that edge quality, that flexibility with the automatic updated holdouts and things like that. So to help answer if this is right, I like to ask the following things. Do I need the entire shot to be rendered in deep? Or can I get away with just a few elements like I've been showing in these examples here? Can I simply use the free deep data that I'm getting out of the scanline render to help modify my work and get the flexibility from that? And how important are the accuracy of things like motion blur, depth of field, and transparency to the shot? If they're not that important, maybe I don't need to invest the time in that. But if they are important, if edge quality is really important, then deep data might be worth investing in for that. Once you know how you want to use the deep data, you can then look at your storage and see if you've got the space for it, and if you've also have the network to pull the files fast enough. Because even if you want these benefits, if you don't have the system in place to allow you to work with it, it's probably going to take a little bit longer. But again, like I showed, you don't need loads of storage or space. You can generate a lot of the deep stuff inside of Nuke itself. So we already touched on generating culling samples while I was padding a little bit out, but it's really important to know that sample management is a big part of working with deep data. And again, we can go in and cull the hidden samples and work with it there. And actually, that brings on a point that I skipped over that really I shouldn't, because it's quite important inside of both working with Deep and working with Nuke. And that's managing your bounding boxes. If I've got a giant bounding box that's got loads of sample data for Deep, that's going to be a massive hit on my performance. So what you do traditionally in 2D compositing is you just use the curve tool, set the curve type to auto crop, hit go, and then you'll get that auto crop data, which means that it really minimizes the amount of pixels that Nuke's trying to process. We can simply create a deep crop node like we did earlier, and we can just copy that across and gain access to that same thing. So just a nice way to also manage your bounding boxes in Deep. So optimizing volumetrics, if you do want to work with volumetrics and you are more of an individualistic artist, like I said, about 10 samples per pixel is a good starting point for non-deep objects. But with volumetric data, the sample should be determined by what objects interact with the volume and by how much. Volumetric complexity typically occurs at points of interaction, so things like feet hits. So go ahead and simulate those as you need to. But then what you can do is you can generate more of a generic fill volume inside as a simpler deep render. And you can do this inside of Nuke using the particle systems. Then while you're working inside of Nuke, you can actually utilize more samples, like put more samples into it with a smaller performance hit as you're not having to read off disk. So finding out these little ways that work with volumetrics can really help add a lot of complexity and depth and interest to your scenes. So with that, I'd just like to thank a few people for helping us build this demo. So first, Aaron Sims Creative for their project. They did fantastic work, and they let me go in and butcher it a little bit for the purposes of this demo. And likewise, Victor Perez for his deep example workflow. I also like to give people who have enjoyed what they've seen but want to go out and find out more some places to go. And Matt Leonard did a fantastic deep dive into deep compositing video series on Sphere VFX. It's a really good course that tackles a lot more content and some of the stuff described here. Also, for those looking to see how Deep's used in production, Robert Hollander from Wetherly did a great video for Rise of the Planet of the Apes when they were first starting to use Deep. And I still think, even though it's an older video, a lot of it still holds true today. And likewise, if you want to get a history and idea of where Deep started and what it was intended for, Mike Seymour from FX Guy did a really good article. So just to quickly summarize, deep data is fantastic for maintaining that edge quality, giving you something really good to work with when you have complex edges like hair or blurring effects, and it'll really help you with holdouts, especially if you have complex scenes that are likely to update. And I think it's important to know that you don't need to be dependent on others to render deep data for you. You can generate your own deep data, start working with it, and really give yourself more knowledge to tackle problems from multiple angles and flexibility inside of comping in Nuke. So with that, I'd just like to thank everyone for coming out and listening. And if you have any questions at the end, feel free to drop by and come say hi. So thank you.